Interstellar space, far beyond our solar system. What a view. Billions of stars like our own sun, many with planets, many of those with moons. It's hard to know which way to go. There are infinite possibilities in every direction. Whichever way, we're going to need a serious burst of acceleration. $40 trillion kilometers from home, a 150,000-year ride in the space shuttle, and we've only just reached the first solar system after our own. Alpha Centauri. One star, and two more beyond. They're spinning around each other, locked in a celestial standoff. Each star's gravity attracting the other, their insane orbital speed keeping them apart. We're so far from home now that kilometers are becoming meaningless. We're going to have to talk in light years. A beam of light takes 1 year to travel 10 trillion kilometers. So 40 trillion kilometers is over 4 light years from home. It's crazy. Distances so vast they're almost beyond comprehension. And exciting. Who knows what strange worlds lie ahead? What we'll discover when, if we reach the edge of the universe. "10 light years from Earth, the star Epsilon Eridani. Spectacular rings of dust and ice, and somewhere in there, planets forming out of the debris, being born before our eyes. Asteroids and comets everywhere. We could almost be looking at our own solar system, billions of years ago, with comets delivering organic molecules, water, to these young planets, kickstarting life just as they may have done on Earth. At the center of all the action, a star smaller than our sun. It's still in its infancy. Any life in this solar system would be primitive at best. There must be more mature, developed solar systems out here, but finding them is like looking for a needle in a cosmic haystack. "20 light years from Earth, star Gliese 581. It's about the same age as our sun. And orbiting it, this planet. It's just the right distance from its sun. Any closer and water would boil away. Any further and it would freeze. Ideal conditions for life to have evolved. And if comets have struck, delivering water and organic materials, then life, complex beings like us, even civilizations like our own, could be down there right now. If there are, even at this distance, they could be tuning into our TV signals, watching shows from 20 years ago. That's how long they would take to get here.
And here's your host, Joe Joplin.
But until future generations can find a way of communicating over these vast distances, all we can do is speculate. Us and them, living parallel lives, unaware of each other's existence. Unless life has been and gone. That's the problem with comets. They're creators and destroyers, as the dinosaurs found out the hard way 65 million years ago. This is the needle in the cosmic haystack, the closest we've come to a habitable solar system like our own, but it's a chance encounter. There could be hundreds, millions more solar systems like this out here, or none at all. It's Algol, the demon star, feared since ancient times. From Earth, it appears as one star that flashes on and off. But up close, we can see in reality, it's two stars, and one is being sucked towards the other. Almost 100 light years from home. Listen. One of the first ever radio broadcasts. Just a faint whisper.
We'd appreciate it if anyone hearing this broadcast would communicate with us. We are very anxious to know how far the broadcast is reaching.
And then, silence. From here on out, it's as if Earth never existed. Any aliens living beyond here will have no idea we're there. It feels like a lifetime ago we looked up at the sky wondering where we fitted in. Now we're learning to appreciate the wonders we're seeing, not just for what they tell us about our own world. It's what they can tell us about the whole universe, its past, and its future. Deep inside our galaxy, the Milky Way. A vast celestial library, each star a book with a story to tell. The Seven Sisters. From Earth, this is the brightest star cluster in the sky. And this giant, Betelgeuse, the brightest, biggest star we've seen so far, at least 600 times wider than our sun. But this, it's not a star, not a planet. Not like anything we've ever seen. A ghostly specter, more than 1,300 light years from Earth, Orion's dark cloud. Dust and gas, so dense it's shrouding us, shutting us off from the universe outside. There, deep inside, a ball of light, pulling the dust and gas towards it, heating it up, merging into a ball of burning hot gas. Like a star, like our sun, in miniature. Inside, temperatures reach millions of degrees. So hot it's beginning to trigger nuclear reactions, the kind that keep our sun shining, making energy, radiation, light. A star is being born. Or rather, stars. Orion's dark cloud is a vast star factory. We're witnessing the birth of the future universe. We came here expecting horrors. Instead, we've discovered one of the universe's greatest wonders: star birth. Jets of gas exploding outwards at 200,000 kilometers an hour, blasting dust and gas out for millions of kilometers. It's unbelievably violent. But look at the results. Nebula, vast glowing clouds of gas, hanging in space. With no wind out here, they'll take thousands of years to disperse. We've seen some strange sights, but this, it's a masterpiece. A giant horse's head rearing up in space. Stars are born, grow up, and then what? Do they die? Do they slip quietly into the night? Or go out with a bang? Somewhere between here and the edge of the universe lies the answer. Nearly 4,000 light years further, luminous clouds suspended in space, encircling what was once a star like our sun. All that's left of it are these brightly colored gases, elements formed by nuclear fusion deep inside the star, released into space on its death. Green and violet, hydrogen and helium, the raw materials of the universe. Red and blue, nitrogen and oxygen, the building blocks of life on Earth. For us to live, stars like this had to die. The oxygen in our lungs, the nitrogen in our DNA, it was all produced by nuclear fusion in stars that died long before the Earth was even born. We are made of stellar nuclear waste. Our family tree begins here. At its heart, the ghost of a star. It's a white dwarf. White, hot. Small, but unbelievably dense. In the star's dying moments, its atoms fused and squeezed together, making it so dense that just a teaspoon of this white dwarf would weigh 1 ton. It's a chilling premonition of our sun's fate. 6 billion years from now, it will become a white dwarf. Its death will herald the end of life on Earth. It makes you wonder how many other worlds have been and gone, stories left untold, celestial books lost forever. But the greatest story of them all is still to be told. We must go back through time to the very first chapter to tell the story of how the universe began. The scattered remains of a dead star, a nebula, the Crab Nebula. We are 6,000 light years from home, deep inside a stellar graveyard. Dust and gas stretching for trillions of kilometers. It looks dead, but maybe this is just the calm after the storm. After a massive explosion, powerful enough to turn a huge star into a cloud of dust and gas. A supernova. Here it is, the eye of the storm. A spinning, pulsating star, a pulsar. Gravity must have squeezed the giant star's core down to this. It's just 20 kilometers across, making it unimaginably dense. One pinhead of this would weigh hundreds, maybe millions of tons. As it shrank, like a figure skater spinning on the spot, arms outstretched, then pulling them in, it began to spin faster. 2 beams of light, energy, radiation, spinning 30 times a second, powering the huge cloud of dust and gas. There's so much radiation here, more even than on the sun. If this pulsar got as close to Earth as our sun, our planet would be instantly stripped of life. That was easily the deadliest thing we've encountered so far. Getting a strange sensation. A feeling as though there's something bad out here. A malevolent presence. The one thing we didn't want to encounter. Impossibly black, blotting out the stars behind it. We're staring into the face of death. The remains of a giant star. A black hole. Instead of contracting to a white dwarf or a pulsar, it just kept on going, shrinking until it got so small, it's just a few kilometers across, far denser than a pulsar, and impossible to resist. Stray too close, and there's no turning back. Now we know why it's a black hole. Its gravity is so intense, not even light can escape. This asteroid, a lump of solid rock, is stretching, being dragged towards the gaping hole. Inside, there's no matter as we know it. No time, no space. All the rules of physics collapse. The asteroid is gone. Truth is, nobody really knows where. We're looking at the limit of human understanding. There could be millions of black holes creeping around our galaxy, more perhaps than all the stars in the sky, but we wouldn't see them until it was too late. Like this star, spiraling, disappearing down an invisible sinkhole. Who's to say we don't live inside a vast black hole? That the whole universe isn't inside one right now, inside another universe. Sometimes it feels like the more we see, the less we know. But we do know our galaxy is more complex and more dangerous than we ever imagined. And we're still in our own galaxy, the Milky Way. The rest of the universe still lies ahead. The wonders, the dangers, the secrets, they're out there. But first, we've got to find a way out of the Milky Way. "7,000 light years from home, still deep inside our own galaxy. It's as though we're in a forest thick with trees, each so beautiful, so fascinating. It's impossible to look beyond, to see the bigger picture. We have to find a way through, reach the clearing at the galaxy's edge. Only then can we begin to understand where it and we all began. But faced with sights like this, it's hard to leave. A colossal glowing cloud topped by these great towers of dust, the pillars of creation. Like a gateway into the far galaxy. Both pillars are studded with tiny bulges, embryonic star systems, each one the size of our solar system. It's another monument to nature's astonishing creativity. But we have to ignore its captivating beauty, tear ourselves away to carry on towards the edge of the galaxy. Dazzled by the Milky Way's beauty, we've strayed into a cosmic minefield. Like an explosion in slow motion, giant clouds of gas bursting out of this star. A star millions of times brighter than our sun. The nuclear reactions that power it are winding down. We're watching its death throes. And beyond it, an even bigger, even more dangerously unstable star. But this one's about to explode. And when a star this big dies, it's 100 times more violent than a supernova. Somehow, we've stumbled into the most violent star death imaginable, a hypernova. The core's collapsed. It's becoming a black hole. And that's the shock wave, surging through the star, ripping its outer layers into space. There's lethal radiation everywhere, enough to have a catastrophic effect on any planet unlucky enough to be nearby. When virtually every species on Earth was wiped out 450 million years ago, the culprit may have been one of these. Deadly hypernovas, frozen comets, scorched planets, white dwarfs, red giants, Earth. Tiny drops in a vast pool of white light. Our home galaxy, the Milky Way. We wanted to know where we fit in. Here's our answer. Civilizations past and present, everyone that's ever lived, the smallest bug, the highest mountain, all of it invisible. Not even a tiny speck. Our home is a minor planet of an insignificant star. If it disappeared right now, we wouldn't even notice. And yet, so far, we've found nowhere else we would rather live. Nowhere we could live. It's only now, far from home, that we can truly appreciate it. But look at all these stars. Hundreds of billions of them. Surely one of these, more than one, must be capable of supporting life. Maybe here, in this swarm of stars, the Great Cluster. Back in the 70s, astronomers sent a message in this direction, detailing the structure of our DNA and showing a plan of our solar system. But it's so far from home. The message won't arrive for at least another 25,000 years. We haven't found alien life yet, but neither have we found any reason to believe it isn't out here, somewhere. There's an equation devised to estimate the number of other advanced civilizations, and the result is shocking. There should be millions of civilizations just in our galaxy. Everything we've seen so far is inside the Milky Way. Now, here's our chance to see other galaxies, to glimpse the even bigger picture, and perhaps to answer the ultimate question: where does all this come from? It's time to leave our galaxy and enter intergalactic space. Beyond the Milky Way, through the vast expanse between galaxies, against all the odds, we've made it to intergalactic space. Out here, there's no horizon in sight. Even the closest galaxies are hundreds of thousands of light years away. The remains of galaxies ripped apart by the Milky Way's huge gravitational pull, scattered through nothing. This is as close as the universe gets to a perfect vacuum. But even this isn't totally empty. There are thin wisps of gas, fine traces of dust, and something else. Dark matter. So mysterious we can't see it, feel it, taste it, touch it, or even measure it. Yet so common, it could make up over 90% of all the matter in the universe. If dark matter does exist, it means there's no such thing as empty space. Even out here, we're surrounded by matter. We only suspect it exists because of the strange hold it seems to exert on galaxies, like this one, the Large Magellanic Cloud. More than 6 billion years in today's fastest spacecraft, 160,000 light years from the Milky Way, at the edge of its gravitational reach. This galaxy should spin off into space, but something seems to be holding it here. Something invisible, powerful, dark matter. Stars, clusters of stars, nebulae. It's a vast astronomical treasure house. But look at this. It's like a string of gleaming pearls. A fireball, expanding out from what must have been a massive explosion, a supernova. So bright that when light from the explosion reached Earth in 1987, it was visible with the naked eye. And so violent, it triggered a string of nuclear reactions, forcing atoms together, creating new elements: gold, silver, platinum, blasting them out into space. The gold in the ring on your finger was forged in a massive supernova like this, trillions of kilometers away, billions of years ago. Before we left home, the universe seemed separate. We were wrong. The universe is part of us. We are part of the universe. It's comforting to remember as we venture through this abyss. Further and further, faster and faster. The Andromeda Galaxy, 2.5 million light years away. It's moving through space at nearly 1 million kilometers an hour. Everything in space is moving apart, like shrapnel from an explosion. We're seeing this galaxy as it was when our ape-like ancestors first walked across the African plains. There's order in this chaos, a pattern behind the infinite variety, an endless cycle of birth and death, creation and destruction. It's a pattern woven through the vast fabric of space that binds each of these galaxies. There are billions of galaxies in the universe, each with billions, even trillions of stars. Possibly more stars than there are grains of sand on all the beaches on Earth. And all these are just the stars that exist now. What about all the stars that have been and gone? All the stars being born, yet to be born. We're finally beginning to see the big picture, and it's bigger than we ever imagined. This galaxy, the huge Pinwheel Galaxy, is so far from Earth that if we send a message home now, it will take 27 million years to get there. Who knows whether our species, our planet, will still be around to receive it. We travel on, back through time, past the point where the dinosaurs were wiped out, past the moment where the first creatures clambered onto land. "2 billion light years from home, closing in on the edge of the universe, going back to the beginning of time." This isn't a galaxy. It's brighter than hundreds of galaxies put together. A blinding beam of energy bursting out for trillions of kilometers. Something this big, this bright, must be incredibly powerful. Experience tells us out here, power equals danger. It looks like a quasar, the deadliest thing in the universe. If it is, then our journey could be over, just as the end is almost in sight. The deadliest, most powerful thing in the universe, a quasar. A swirling cauldron of superhot gas, brighter than hundreds of galaxies. The source of this awesome power lies deep inside the heart of the beast. A heart of darkness. A supermassive black hole as heavy as 1 billion suns. It's ripping apart whole stars, sucking their gases into the quasar, devouring them, until they're nothing, lost forever from the visible universe. We've seen the worst the universe can throw at us. Its most powerful destructive forces. Now our path is clear. The very edge of the universe is almost within reach. But we still need to go further, faster if we're to cross the final reaches of the universe. "8 billion light years from home. More galaxies. But these look different. Ragged, small, close together. We're so far back in time, we're seeing these galaxies as they were before the Earth was even born. They're still young, still growing. We're getting closer to where and how it all began. 12 billion years ago. Look at the galaxies now. They're more like primitive plankton floating in a vast, dark ocean. It's magical. Clouds of dust and gas, dancing, forming a shape, merging to make embryonic galaxies. This is how our own galaxy was born. They're disappearing. We've gone back before the stars were born, into a cosmic dark age. And before that, light. The afterglow from a massive explosion, the explosion which created the universe. We're almost there. This is it. We've made it. The edge of the universe. 130 billion trillion kilometers from home. 13.5 billion years ago. The very instant of the Big Bang. The most violent, most creative moment in history. Everything that's ever happened follows from this moment. Every religion, every culture has pondered it. But we still don't know what sparked this act of creation, or why. This is where our journey ends, and the universe begins. The edge of the universe, 13.5 billion years ago. At the single most important moment in history, the beginning of history itself. An infinitely hot, small, dense point erupts. The Big Bang. Creating space, time, matter, our universe itself. First, it's the size of a subatomic particle. The tiniest fraction of a second later, it's big enough to hold in the palm of your hand. Moments later, it's the size of the Earth. Today, the light from the Big Bang is still spreading out as a hiss of radio static. Your TV aerial picks it up. You can see it as static on an untuned TV. We go on, forwards through time. All the things we've seen on our journey are sparks flying out from the Big Bang. Galaxies, stars, planets, all just debris. Back through our galaxy. Our solar system. until we reach another cooling cinder, swirling in the afterglow of the Big Bang, the Earth. After a 260 billion trillion kilometer journey, we're back where we started. Home. Only now can we really know it. Now we know our home is smaller, less significant than we ever imagined, and destined to die, swallowed by a dying sun. But we shouldn't despair. We should rejoice in the knowledge that from our remote little outpost, we've managed to discover all this, to unlock the secrets of the universe. We should celebrate our achievements, cherish our home, and enjoy our moment in the sun.